Here's problem 1132. What is the angular momentum of the moon about the Earth? The mass of the moon is 7.35 times 10 to the 22 kilograms. The center-to-center separation of the Earth and the moon is 3.84 times 10 to the 5 kilometers, and the orbital period of the moon is 27.3 days. Alright, so if we had an image of the Earth and the moon, we have this distance r, and we're given an orbital period of 27.3 days. Well, knowing that there's 24 hours in a day and 3,600 seconds in an hour, so with the hours canceling out and the days canceling out, this gives us an orbital period of 2.36 times 10 to the 6 seconds. That's the time it takes for the moon to go around the Earth. Sounds good. Well, in general, the angular momentum of an object in orbit is going to be the mass times the linear velocity times r. We could write this as the mass. Now the linear velocity on average is going to be the total circumference of that orbit, 2 pi r, over the period of time it takes to complete that, times r. So we can write this as mr squared, if we will, times 2 pi over the period. Well, this is indeed equal to the moment of inertia of a point mass about a central object, mr squared, times 2 pi over the period is the angular velocity. So this is indeed equal to the moment of inertia times the angular velocity of the moon. Sounds good. Well, we have the mass of the moon times r squared, so we have 7.35 times 10 to the 22 times the radius of the orbit, 3.84 times, now 10 to the 5 kilometers is 10 to the 8 meters. We'll square that, times 2 pi over the period, 2.36 times 10 to the 6 seconds. And this is equal to 2.89 times 10 to the 34 kilogram meter squared per second. So that is the angular momentum of the moon about the Earth. 2.89 times 10 to the 34 kilogram meter squared per second.